In this video, we're going to explore the topic partial fraction decomposition. Alright, suppose you have a rational expression n of s over d of s, where d of s not equal to 0, and n of s represents the numerator. D of s represents the denominator. Step number 1. If the degree of n of s is greater than the degree of d of s, we're gonna perform long division. Alright, if you want to review how to perform long division, please check out the link in the description below. Alright, so suppose after you perform long division, n of s over d of s becomes a polynomial plus r of s over d of s, where r of s is the remainder of this long division. If the degree of n of s is less than the degree of d of s, we're gonna skip this step, right? Now step number 2, factor the denominator d of s completely. Now if you want to review how to factor the trinomial, please check out the link in this description below. Now if the denominator has linear factors, d of s equals as plus b raised to the k. Then if the degree of n of s is greater than the degree of d of s, we're going to use the remainder 1, which is r of s over d of s right here. After you perform long division, right? S to b, a1 is a constant over as plus b is the linear factor. So remember that the top always 1 degree less than the bottom, right? The bottom is linear, the top should be constant, right? Now a2 over as plus b squared, right? Until raised to the k right here, right? Now if the degree of n of s is less than the degree of d of s, which is the one we skip step number 1, right? So we're gonna take the original one right here. We don't need to perform long division, right? N of s over d of s equal a1 over as plus b, a2 over as plus b squared, right? Similar to this one, right? The only thing different right here is this guy and this guy, right? Now if the denominator has quadratic factors like as squared plus bs plus c raised to the k, and then we do exactly the same thing on the top, right? Now the only thing different right here is the bottom is the quadratic factor, then the top should be the linear factor, right? 1 degree less than the bottom, so keep that in mind. Everything else should be the same, right? Now step number 3, write each partial fraction on the right in the same denominator, which is this one right here, as the rational expression on the left right here. Then solve for the coefficients a1, a2 all the way to bk right here. We need to solve over this, right? Now note that each term on the right is a partial fraction, right? This one is the partial fraction. And that sum is the partial fraction decomposition of the rational expression on the left, right? Now let's move on to example number 1. What is the partial fraction decomposition of s plus 14 over s squared minus 2s minus 8? Now we're going to check the degree on the numerator and degree on the denominator. Obviously, this guy is less than this guy, right? So we don't need to perform long division, right? So we're gonna skip step number 1 right here, right? So we're gonna move on to step number 2. We need to factor the denominator completely, and then we're gonna use the original one right here, n of s over d of s. We're not gonna use the remainder, right? Now I'm gonna factor the denominator, right? So I'm gonna use s partial, right? Now I need to find two numbers multiply equals negative 8 add up to negative 2, which is negative 4 and 2, right? So s plus 14 over s squared minus 2s minus 8 equals s plus 14 over s minus 4, which is this guy, times s plus 2, which is this guy, right? The next step is you're gonna separate these two guys, right? So it's gonna be a over s minus 4 plus b over s plus 2. You can use c, d, e, f, whatever, right? It's just a dummy variables, right? Now the bottom right here, observe that it's gonna be the linear factor, so the top should be a constant, right? Now we're gonna focus on this guy only, right? We don't need to worry about this guy anymore, right? Now I'm gonna multiply both sides by the LCD, which is the least common denominator right here, right? So if I multiply both sides by this guy, the left hand side becomes s plus 14, right? The right hand side right here, I have s minus 4, but the LCD is s minus 4 plus s plus 2, right? Does that mean I miss s plus 2, right? So I need to multiply the top bottom by s plus 2, right? So it could be a times s plus 2, right? Plus b, this one right here, I miss s minus 4, right? So I multiply by s minus 4, right? In order to solve for a, I need to eliminate b, right? In order to eliminate b, I need to let s equal 4, right? Because 4 subtract 4 equals 0, right? So I'm gonna let s equals 4. Then substitute 4 for s over here. I have 4 plus 14 equals 18 equals a times 4 plus 2 is going to be 6, right? Now 4 subtract 4 is going to be 0, so b is gone, right? Now from this guy, I can solve for a, it's going to be 18 divided by 6, it's going to be 3, right? Similarly, I'm going to let s equals negative 2 to eliminate a, right? So I substitute negative 2 for s, it's going to be negative 2 plus 14 is going to be 12 equals negative 2 plus 2 is going to be 0, so a is gone, right? You have b left, right? Times negative 2 minus 4 is going to be negative 6, right? So then divide both sides by negative 6, b equals negative 2, right? Now we're going to make conclusion. Original one is right here, equals a over s minus 4, but a equals 3 right here. So it could be 3 over s minus 4 plus b, it's going to be negative 2 right here, over s plus 2, right? So I can rewrite this one as 3 over s minus 4. This guy becomes subtraction, 2 over s plus 2. This one is the final answer. Now let's move on to example number 2, repeated linear factors. Now observe that degree on the numerator is bigger than degree on the denominator. So we need to perform long division, right? S to the 4 divided by s cubed, you have s, right? Multiply this guy back, you have s to the 4. S times 2s squared could be plus 2s cubed. S times s could be plus s squared, right? S to the 4 subtract this one, 0. This guy, 0. This guy, 5s squared, right? So we're gonna print this guy down, 20s plus 6, right? Observe that degree right here is 2. Degree right here is 3. This guy less than this guy, we're gonna stop, right? So this guy can be written as the quotient is this guy right here, s, plus the remainder is right here, over the divisor is right here. Now what we need to do is to decompose this one, right? So before we're gonna do that, we need to factor the denominator, right? So we factor s out, so it could be s times s squared plus 2s plus 1. And this guy actually complete square formula, right? So it could be s times s plus 1 altogether square. Remember we have a squared plus 2ab plus b squared. It could be a plus b altogether square, right? So this guy right here becomes, now we look at the bottom right here, we actually have two linear factors, right? But this linear factor is repeating, right? We need to handle the first linear factor right here. It's going to be a over s, right? Because the bottom is linear factor, the top should be the constant. Plus the second linear factor right here, s plus 1, right? And we need to start from power of 1 until 2 right here, right? So it could be b over s plus 1, right? Plus c over s plus 1 altogether square, right? Because the linear factors is repeating, right? We look at the notes right here. If the linear factor repeating, we need to rewrite this one until we reach the highest power, right? Now, we have the LCD right here, right? And we only have s, we miss s plus 1 altogether squared, right? So we need to multiply the top bottom by s plus 1 altogether squared, right? So a times s plus 1 altogether squared, right? Plus, now this one right here we have s plus 1 only, but we need s and s plus 1 squared, right? So does that mean we miss s and s plus 1, right? So this one is b plus c times s only, right? Because we have s plus 1 square already, right? So we miss this guy. Now the left hand side right here, we just write the numerator, that's it. Now we need to solve for a, b, and c, right? So I need to solve for a first. In order to solve for a, I need to eliminate b and c, right? In order to eliminate b and c, I just let s equal 0, right? If s equals 0, this guy gone, right? So I let s equals 0. Then substitute 0 for s over here. This guy becomes 0. This guy becomes 0. We have 6 left, right? Equals substitute 0 for s over here. We have a only, right? So a equals 6. I need to solve for c first. So in order to solve for c, I just eliminate a and b by letting s equal -1, right? So I let s equals -1. So then substitute -1 for s over here. I have 5 times 1, it could be 5. 20 times -1, it could be -20, right? So 5 plus 6, it could be 11 minus 20, it could be -9 equals s equal -1, this guy gone, this guy gone, right? I only have this guy left. C times -1 equals -c, so then c equals 9, right? Now I need to solve for b, right? So in order to solve for b, I just let s equal any number, right? And I use a and c over here, right? So I let s equals 1. So then I substitute 1 for s into this guy right here. So then I have 5 plus 20 plus 6 is going to be 31 equals s equals 1. Substitute over here. I have 1 plus 1 is going to be 2. 2 squared equals 4. 4 times a. But a equals 6. So it can be 24, right? Now substitute 1 for s over here. I have 1 times 2, right? It's going to be 2. 2 times b, right? So it could be plus 2b. Substitute 1 for s over here. I have c times 1, it could be c, but c equals 9, so it could be plus 9, right? Now from this one, I just solve for b, right? So then I have 24 plus 9 is going to be 33 plus 2b equals 31, right? Subtract 33 both sides, so 2b equals -2, and then b equals -1, right? So we have 3 values, a equals 6, b equals -1, and c equals 9. I go back over here. I have s, right, plus this guy right here. But this guy right here equals this guy right here, right? So it can be 6 over s plus b over s plus 1. But b equals -1, right? So I just write -1 over s plus 1, right? And c over this one, but c equals 9 right here, so it will be plus 9 over s plus 1 square, right? This one is the final answer. Now let's move on to example number 3. Distinct linear factors and quadratic factors. So basically, you have both linear factor and quadratic factors in the same problem, right? Now, we're gonna rewrite this one. This guy right here is the degree on the numerator right here is less than degree on the denominator. So we don't need to perform long division, right? So we only need to factor denominator. That's it, right? So I just rewrite the top is going to be 3s squared plus 4s plus 4 over factor s out. It's going to be s times s squared plus 4. That's it. You cannot factor this one anymore, right? So the bottom becomes the linear factor right here and the quadratic factor right here, right? So it can be a over s, right? The denominator is the linear factor. The numerator must be a constant, right? Plus, now the second factor right here, s squared plus 4. Denominator is the quadratic factor. So the top should be the linear factor, right? So it should be bs plus c. So keep that in mind. Now observe that this one is the LCD, right? For the first fraction right here, we mix s squared plus 4, right? So I will write this one right here. Multiply the top and bottom by s squared plus 4. So I have 8 times s squared plus 4, right? Plus this guy right here, I have the quadratic factor already, right? So I miss this guy right here, right? So multiply the top and bottom by s. It's going to be bs squared plus cs, right? Now, it's going to be 3s squared plus 4s plus 4, right? I distribute this one, it's going to be a squared plus 4a, right? Plus bs squared plus cs. Now I need to rewrite this one as this guy and this guy have the same common factor s squared. I factor s squared out, so it will be a plus b times s squared, right? And plus cs plus 4a. So basically, a plus b right here equal 3, right? Now c right here equal 4, right? And 4a right here must be equals 4 right here. Now I solve a system of 3 equations right here. C equals 4. 4a equals 4. Divide both sides by 4. It's going to be a equals 1. Substitute 1 for a into the first one right here. I have b equals 2, right? So then I substitute this guy back over here, right? So I have the final answer. A over s. A equals 1. So it can be 1 over s plus bs plus c. It's going to be 2s plus 4 over s squared plus 4. This one is the final answer, right? Now let's move on to example number 4. Repeated quadratic factors. This guy can be written as, now look at the bottom, it's going to be quadratic factors, right? So the top should be linear factor, right? So it could be a s plus b over s squared plus 2, right? We're going to start from the power 1 until we reach the highest power right here, right? Plus the bottom still quadratic, right? So it's going to be cs plus d over s squared plus 2 power of 2, and we stop right here, right? Now the LCD is this guy, right? So for the first one right here, we mix s squared plus 2, right? So 8s cubed plus 13s, right, equals as plus b times s squared plus 2, right? Now the second one right here, we don't miss anything, right? This guy actually LCD, right? So we only have cs plus d rewrite, right? So it's gonna be 8s cubed plus 13s equals distribute this one. As times s squared is going to be as cubed plus 2as plus b as squared plus 2b, right? Plus cs plus d, right? Now I rearrange this one from highest power to lowest power, right? So it can be 8s cubed plus 13s equals this one right here is the highest power, right? And then this guy right here plus bs squared, right? Now this one right here and this one right here power 1, right? I factor s out, it's going to be 2a plus c times s, right? And you have a constant right here plus 2b plus d. As cubed plus 13s, I can rewrite this one as 8s cubed plus 0s squared, right? Plus 13s plus 0, right? So I have a system of 4 equations. The first one, coefficient of s cubed must be equals 8 right here, right? So a equals 8. Second one, coefficient of s squared b must be 0, right? Third one, 2a plus c must be 13, right? Right here. And the last one, 2b plus d must be 0 right here, right? So then it's going to be a equals 8, b equals 0. Substitute 8 for a into the third one right here. You have 2 times 8, it could be 16, subtract 16 both sides, so c equals -3, right? Substitute 0 for b into the last one right here, so you have d equals 0, right? So then we're gonna substitute this guy back over here, right? So we have the final answers 8 as b equals 0, right? Over s squared plus 2 plus cs plus d, but c equals -3, right? So I have -3s over s squared plus 2 altogether squared, right? Now, right here, you need to be careful with the negative side right here. Since you only have one term right here, you can put negative side right here. But suppose you have two terms right here, like 3s plus 1 or something like that. You cannot put the negative side right here, right? You need to put the negative side right here. And this guy right here becomes the plus sign. So keep that in mind. Now, let's move on to the last example. Repeated linear factors and quadratic factors, right? So this guy can be written as, this guy is the linear factors from s then s squared, right? So we deal with this guy first. So it can be a over s, right? And then plus b over s squared, right? Now we're gonna deal with the quadratic factor right here, right? So it can be cs plus d over s squared plus 1, right? And then es plus f over s squared plus 1 altogether squared, right? Now I just rewrite the left hand side as plus 5, right? Equals. Now the LCD is right here. For this one right here, you mix s times s squared plus 1 altogether square, right? So it could be a times s squared plus 1 altogether square, right? Now for this one right here, you mix s squared plus 1 altogether square, right? So you're gonna multiply by b, right? So it could be b times s squared plus 1 altogether square. Now for this one right here, you mix s squared outside right here and s squared plus 1, right? Because you have s squared plus 1 square, right? So you have cs plus d times s squared plus 1, right? And the last one right here, you only miss s squared, right? So it's going to be plus es plus f times s squared, right? Now we're going to distribute the right hand side. So s plus 5 equals. We're going to use the complete square formula a plus b all together square. It could be a squared plus 2ab plus b squared to expand this guy right here. Right? So it could be a s times s to the 4 plus 2s squared plus 1, right? And this guy is same thing, plus b times s to the 4 plus 2s squared plus 1, right? Now this guy we just distribute s squared, right? So it could be plus cs plus d times s to the 4 plus s squared, right? And the last one, distribute this guy. So it could be es cubed plus fs squared, right? Now distribute this guy one more times, right? So we have s plus 5 equals as to the 5th plus 2as cubed plus as, right? Plus distribute this guy. It's going to be b s to the 4 plus 2b s squared plus b plus distribute this guy. It's going to be c s to the 5th plus c s cubed plus d s to the 4 plus d s squared, right? And rewrite the last two right here, es cubed plus fs squared, right? Now rearrange this one from highest power to lowest power, right? So I have s plus 5 equals this guy and this guy right here. We factor s to the 5th out, right? So we have a plus c times s to the 5th, right? Now this guy and this guy factor s to the 4 out. So it could be b plus d times s to the 4th, right? Now this guy, and this guy, we factor s cubed out. So it could be 2a plus c plus e times s cubed. Now this guy, and this guy, we factor s squared out. So it could be 2b plus d plus f s squared, right? And we have the linear factor right here, as, right? And the constant right here, b. Now you just equate the coefficient, right? The left hand side we don't have s to the 5th, right? Which is coefficient equals 0, right? So we have a plus c equals 0, right? S to the 4 we don't have it, so it could be b plus d equals 0, right? Now we don't have the coefficient of s cubed, right? So it could be 2a plus c plus e equals 0. Again, we don't have the coefficient of s squared, so it could be 2b plus d plus f equals 0, right? We have the coefficient of s, right? It could be a equals 1 right here, right? And the last one, the constant right here, b equals 5 right here, right? Now we're going to solve this one. A equals 1, right? B equals 5, right? Substitute 1 for a into the first one right here. We have c equals -1, right? Substitute 5 for b into the second one right here. We have d equals -5, right? Substitute a and c into this one right here to solve for e, right? So we have 2 times 1 plus -1 right here, c equals -1 plus e equals 0, and then e equals -1, right? Substitute b and d into this one right here to solve for f, right? So we have 2 times b, but b equals 5 plus d equals -5 plus f equals 0, then f equals -5, right? We substitute this guy, this guy, this guy, this guy, this guy, and this guy into this guy right here, right? So we have, and this guy is the final answer. Now, here's 5 problems for you to practice, and it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.